CloudDB, shaping your new normal.
All right. Welcome, everyone, to the 2021 APAC Groundbreakers Virtual Tour. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. We also will have an option of playback in 2 more days. That means you need to register to the sessions, even if they already passed the live one. And then in your own agenda in the system, you'll be able to access the replays. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, creating and configuring Node.js application for Oracle database, presented by Christopher Jones and Sharad Chandran. Please feel free to write questions at any time during this session by using the chat tab at the live webinar that is in the right bottom corner of your screen, and the speakers will be answering them at the end of the session. If there is any issues during the presentation, please feel free to contact me by using the same chat tab, and I will try to help you the best I can. Now, without any more delays, I would like to leave you with this amazing session by Christopher and Sharad. Christopher, Sharad, it's all yours.
Thank you very much. What a great introduction. Appreciate that, and welcome everybody, live or watching the playback. My name is Christopher Jones. As mentioned, I'm here with my colleague Sharad. We are from the Data Access Development team in the Oracle Database Group, talking today about Node.js applications for Oracle Database. So our wider group looks after all of these data access APIs, drivers, modules, interfaces, whatever you like to call them, for languages which talk to Oracle Database. And Sharad and I in particular look after the C-Stack APIs, and we have some wider responsibilities for things like Instant Client and CMAN TDM, some of these buzzwords you know. Sharad's had a couple of really great blog posts out recently on things like this. Today, obviously, we're going to be talking about Node.js. So, a few slides introduction while we're kind of waiting for everybody to join. Node-oracledb is the module for accessing Oracle Database through the Node.js environment. It's usable with the JavaScript or the TypeScript nodes of Node.js. It's installable from standard NPM registry repository. Sources on GitHub, there are examples, there's documentation, we maintain it, there's a lot of testing which goes on, there's command line tests out there, and then we run our own internal stress tests, which are integrated with our whole Oracle Database framework. So it's quite a solid driver. It's been out for nearly 6 years now. And we're seeing a lot of downloads, a lot of customers using it for all sorts of various purposes. Should take a moment to thank all of the contributors to it as an open source project. In particular, Dan Beglin at the moment is looking after our TypeScript definition files. Appreciate him and his company for letting that work happen. Features, sadly not going to have a time to talk about all of these things today. We've got another session coming up, so we'll talk a little bit more about some of these in the start of October. Have regular releases. We just had our 5.3 release out a couple of weeks back, which introduced two-phase commits, something I'm sorry we're not going to be talking about today. But I will throw over to Sharad, who's going to start and give you a good explanation. What are we going to cover today, Sharad?
Thank you, Chris. So today, Chris and everybody, we are going to talk about the following topics. We are going to talk about different ways of connecting and communicating to the Oracle database using node-oracledb. How do you get data in and out using node-oracledb? And then we will look at how node-oracledb works with JSON or SODA, which is OracleDB's NoSQL document store API, which we'll talk about in a short while. Moving on, just quickly, sorry.
A slight time delay on some of these, but
yeah, my apologies. But before all that, let's take a peek at node-oracledb under the covers. So as you can see in this diagram here, we have some users on the left who are making some network requests. perhaps from an Angular app or other REST or GraphQL calls. So when they try to do some data processing, they go through node-oracledb. So node-oracledb here sits in the middle tier. It may sit as part of an app server or as part of a microservice executing the application JavaScript, and it makes call to the node-oracledbs to get some data from the Oracle database for processing. Now, node-oracledb will communicate to the Oracle database sitting on-prem or on cloud, and it will perform the required database operations, whether it be fetching data or whether it is data loading or any other data processing operation. So moving on, I just wanted to touch a bit about the Oracle client libraries which are used by node-oracledb. A lot of users ask us questions on why Oracle client libraries are so important. Well, they provide all the data processing functionality out of the box. Oracle client provides us data access, performance capabilities, high availability, and much more. And it is very important for us that Oracle client libraries perform efficiently, and node-oracledb in particular makes full use of all the functionalities that are present in Oracle client libraries to do its data processing operations. Moving on, Oracle client libraries makes use of the Oracle net layer. Oracle net layer is not a product per se, but it is the way in which node-oracledb and thereby Oracle client libraries communicate with the database. Oracle Net provides some great functionality as far as the network layer is concerned. They provide connectivity, failover functionalities, encryption, checksumming, and much more. And typically, you configure at the net layer using the network configuration files of database such as sqlnet.ora or tns-names.ora. Quick tip here, in node-oracledb, you will see a lot of features about network capabilities such as encryption, checksumming, connectivity, etc. But primarily it is done by the Oracle net layer. So to sum it all up, node-oracledb is a thin layer which is built on technology stack of Oracle, which is very well tested and efficient. So this is one quick slide to get you acclimatized to node-oracledb. There are various styles of coding available for node-oracledb. Of course, we had the earlier old school callbacks and promises, which is still supported. But here in this slide, we show you the async await model. It is which is the latest model introduced in Node.js. It is much more efficient, much less error prone, and it makes it easier for the user or the developer to understand what is going on. And we definitely recommend using this style if you're starting to code any application using node-oracledb. However, if for any legacy reasons or any other reasons, you can still continue to use the callbacks and promises also with node-oracledb functions in case you are interested in that. And just quickly running through the code. So you have the fairly standard Oracle model where you use the get connection function to establish connection to the database. A small tip here, we have hard coded the password, but it is generally recommended that you have the password from an external authentication, or you have it from a wallet, and you do not hard code a password in your application that you're running. Once you get the connection, you execute it using you execute any SQL query to the connection using execute function. And of course, once you get the data, you can do whatever processing you want in your application with the data. Also, we have the close function. It's always good to close the connection. And on the right, you can see the result of this sample example that we have run so far. So moving on to the next slide. Here we are going to get working with node-oracledb and look at all the features and all the important features, at least, of node-oracledb. Let's quickly talk about connecting with node-oracledb. Before that, we would need to install node-oracledb. So what are the prerequisites for it? First, we install Node.js from the Node.js repository. Next, we install the Oracle. Next we install the Oracle Instant Client. Oracle Instant Client is available for download from Oracle portal, or you can, if you're using Oracle Linux, you can download it from the Yum repository as well. Quickly moving on, once you have installed all these prerequisites, you configure your application using package.json file and app.js. Important thing to note here is that in the package.json, you add node-oracledb as one of the dependencies. And quickly in the next once you have created and you are done with your package.json and your app file, you install all the dependencies using npm install command, and then you can run your application using npm start command. So all these quick start instructions are available on on oracle.com. So we would definitely like you to check it out. Next slide, please. Okay. So here we are talking about initializing the Oracle client libraries. So so for a Node Oracle DB, as we had told earlier, Oracle client is a must. So we need to set Node Oracle DB. Before you connect, you need to ensure that Node Oracle DB is aware of where Oracle client libraries are. So here I am showing one method by which you can connect Node Oracle DB to the Oracle client libraries. So this is the in-app method by using init Oracle client and libdir attribute to point to the Oracle client libraries. This is so this in-app method is used in Windows. You can use it in Mac OS as well. But alternatively, if you do not want to point to the Node Oracle you do not want to point to the Oracle client libraries in Node Oracle DB, you can set the path environment variable beforehand before you run the application. You can include the client libraries in the path environment variable, and then you can run your application. So moving on, this is for,
let me talk about this one, shall I, Sharon? So I'm a Mac person, you're a Windows person. So it's the same thing as Sharon just mentioned on Darwin, which is Mac OS. We can use the init Oracle client method. We don't have the option of setting a path. Apple has really clamped down on dynamic loading of libraries. But if you, in your package.json file, add a post-install script, that will run as part of the install when you do that npm install that Sharon showed. Create a symbolic link to your libclient.sh, part of the Oracle instant client libraries, and then all of your apps will run without needing the init Oracle client call above, similar to the setting path. So as you can see there, it does this sort of $npm root. That's the maps down to the Node modules directory that Node likes to use. And I guess I'll just do Linux as well. I used to work in a Linux group. So unfortunately, the init Oracle client doesn't do what you'd really like it to do on Linux for various reasons to do with third-party libraries we have in the security area. And so you need to set your system library search path before you start your Node application. And the easiest way is to install RPMs, which do all of this for you, so you don't need to actually do anything at all externally. But if you are installing the zip packages, then you can run this ld config shown on the screen in the typewriter font, or you can set the traditional LD library path, although that can be error prone in some environments, can get cleared out if you're running through web servers and things like that. LD config is much better, but you just need to make sure that you're not setting that as the default library search path and conflicting with our other Oracle applications on the system. So shared pooling is a hot topic.
Yeah, thank you, Chris. Yeah, let's talk about pooling now. So in one of the earlier examples, you might have seen that we talked about standalone connection. There was just a single connection. However, standalone connections can be expensive to scale up because each use involves authentication, creating a DB server process, getting the network listener to wake up, need to allocate some session memory at the end, and finally you have to destroy the process. So you have to do this for each one of those standalone connections, which is expensive and frankly quite impossible to scale up for multiple users. So in that scenario, most of the application programs, they will use a connection pool. The connection pool will remain open for the lifetime of the application. And as you can see in the diagram here, they basically hold the pipeline to a bunch of connections, and the number of connections that it can hold are controlled by the pool parameters such as pool min, pool max, pool increment. So you can have a sort of a dynamically growing pool based on these parameters. And yeah, when you quickly run it, now coming to the code that you see on the screen, you can use the create pool function to create the pool along with the pool parameters to control the growth rate or growth size of the pool. And once you create the pool, you can get the connection from the pool. You can quickly use the connection, and then you can use the connection close command. So if the connection is part of the pool, the connection pipeline is not actually closed. The connection is returned to the pool, and it is ready for use by any other user, or any other operation if need be. So moving on, next one. So quickly wanted to touch about closing the pool as well. So if you're closing the pool, there is a parameter called the drain time parameter, which you see over here. Here it is set to 0, which means the pool is immediately closed, and any existing or new connections will also be closed immediately. However, you can set this number parameter to a positive number. In that case, it will stop the new connections, new users from connecting. But if there are any existing users, it will allow them to complete their work within that allocated time that is provided in the parameter. So next slide, please. Okay. So talking about connection storms, we generally have some feedback from our performance team that it is always good to make your pools static. So main reason is to avoid DB connection storms, which are multiple connections coming in and overloading the database. So one possible way to avoid this is to set pool min equal to pool max parameters and set the pool increment to 0. So this will make your pool as a fixed size pool and ensure that your system is stable and your resource usage and available is quite predictable. Resource usage is available and availability is quite predictable. I'm sorry. So moving on. Just one tip before that: the fixed pools do not suit every use case, but it is always useful for most stable systems. Okay. Let's now look.
Sharon.
Yeah, I'll throw it to Chris. Yeah.
Okay. So the follow-on from the real-world performance tuning team's tip is that they like small pool sizes. So we recommend that. That then can have some implications if you have sudden spurts and dynamic load growths. But let me just talk through that a little bit. You see here on this slide, you've got 3 users, 3 pipes in gray open to the database being used. That yellow pipe is an open connection, which isn't being used at this stage. So in this case, pool max would have been 4. Maybe pool min would have been 4. So at initialization, we have 4 connections, 4 pipes open to the database, 3 of them in use. And fourth person comes along, they grab that 4th connection and start using it. But what happens if you have more users come in? You've only got 4 connections in the pool. These extra 4 users go into a pool queue, which node-oracledb maintains. And that pool queue can increase in size, and those connections just sit there waiting, not being actioned. The users sitting there not getting response back from the pool .get connection call until one of the initial users finishes with their connection and releases it back to the pool. And then we pop something off the queue, pop a request off the queue and give it a connection to use. Now there's a queue timeout parameter. So if people are waiting in that queue for a very long time, they can be timed out and they'll get connection call will just return an error, NJS 040. So that lets the pool cope with some dynamic load issues, means you don't have to suddenly create a pool size of 8 and have 4 connections unused most of the time. You have a little bit of time delay while people are waiting in the queue, but not very much. So we have a much better performing application overall. The queue itself actually does have an upper limit, this thing called queue max, which by default is 500. And by the way, the queue timeout on the previous slide was 60 seconds. You can tune that. But here, the queue max size of the pool by default is 500. So if the 501st get connection call comes in, that user will immediately, without waiting for any timeout, get this NJS 076. So this is helpful if you're not using some kind of load balancer that already has some kind of protection against denial of service or accidental or deliberate denial of service attacks. And any request in the queue actually will wait for that timeout, but any new request will immediately get this particular error, NJS 76. So we've seen these couple of things come in, being very useful for people to understand, particularly when their application isn't coded very well. when they're not doing that closed connection at the end of using the connection, and so the application's kind of hogging that connection, and eventually the pool fills up with kind of open, acquired but not being used connections, and new users come in. These kind of things are very useful in development, so you can work out whether or not your application is coded correctly. So I want to walk through a little scenario. Let's pretend we have pool max is 10, so you've got 10 connections in the queue, and you've got 10 users executing SQL statements. And you might think everything's good, but unfortunately you might see deadlocks or low throughput. And the reason for this is that Node.js has 4 worker threads by default, and these are the original worker threads, part of the system of Node, not the user level worker threads, which are a relatively recent introduction to Node. But by default, these internal worker threads for passing off long running operations are limited default to 4. And so only 4 of your users are actually going to be doing work at any time, because those other 6 connections are blocked waiting for a thread to give them some CPU time. So the solution is to actually increase that number of default threads, and Node.js uses the UV thread library, and so there's a UV thread pool size, and typically you need to set this before the application starts. In some cases you can set it inside the application, but it needs to be set before the pool, the thread pool itself starts, and that can be tricky to work out. Much safer to set it before the application runs itself. This is the Linux syntax. Windows, you'd use a set. And by the way, on Windows, you have to set it before Node starts. You can't actually set it at runtime after the process has started. So this is a fairly simple way to set it. And you might want to actually increase UV thread pool a little bit bigger than the number of connections in the pool. Maybe there's some other non-database work going on in parallel as well. If you have multiple pools or you're using standalone connections, the same thing occurs, same thing applies. You need the UV thread pool size to be bigger than the total number of connections in the process. So Sharad, I'm going to throw back to you. This is something you've had a blog on recently.
Yes, Chris, thank you. So just a quick detour on Oracle Autonomous Database on cloud. So here we have the cloud console that you see here on the screen. So currently we would like our node-oracledb app to use the mutual TLS or the two-way TLS model that the cloud provides, which gives enhanced security. So what if your node-oracledb wants to talk to an Oracle cloud database? Well, for that, you need to first go to the you need to open the cloud console. You need to go to the CloudDB's cloud console, and then you can click on the DB connection button that you see over there. That will open up another window where you will see the download wallet button. You need to click on that and then download the wallet to your local machine. And from that you can extract these 3 files that you see here on the screen. This is the most important file is cwallet.sso file, which contains the TLS that we talked about. You will ideally move them to a default location of your Oracle home, which is network admin location. And once you have moved the wallet, and once you have set the TNS alias for this ADB in tnsnames.ora, you can connect in node-oracledb to the cloud database, similar to how you had done earlier. So just a quick tip, and one more tip: if you do not have access to the network admin folder, default network admin folder, you can move those 3 files to any arbitrary directory. But there are 2 additional things that you need to do here. One is you need to edit the sqlnet.ora file to set the path to the cwallet.sso file, which contains the TLS. You can do it using the wallet location syntax that you see over here. And in your node-oracledb application, you need to set an additional attribute called config directory along with your init Oracle client function call. Alternatively, you can also export. You can also set the tns_admin environment variable. But these are some of the additional setups that you need to do in case you're not using the default network admin directory. So
Sharad, I should just point out that the walletless one-way TLS is coming soon. Java people already have it available from the cloud. It's not quite there in the C stack, but it's being actively worked on. So just follow along our blog, and we'll be telling you when that's available.
Yeah, thank you. Thanks for that input, Chris. So quickly, let's talk about fetching data. Give me a second while it reflects on my screen here. Okay, so let's now before we talk about fetching data, we need to talk about round trips. So typically a round trip is the trip from the client to the server and then back. The round trips will increase number of round trips will decrease the efficiency of your application. It's always good to optimize your round trips. So some minor tips to optimize your round trips on the application side is that you can use client result caching and ensure that you always do not over roll back or do not over commit all your SQL transactions. And if there is a choice between a bunch of SQL transactions and PLSQL statements, always use PLSQL statements. And also, if you're doing any network pings, it is better to avoid or keep the number of explicit network pings to as a minimum number as possible. So next slide. So there are actually, talking about fetching data now in an efficient manner, there are actually 3 ways in which you can fetch the data. Usually the most common method or the most usual method is to just use the execute function to execute the query and then fetch the data. All the rows will be returned in this case based on the memory size. But if you want to fetch, if there is a large number of rows, then you can fetch it in batches. For that, you need to set the result set attribute with your execute function, and then you can get the rows one by one by using getRow function, or you can get a batch of rows by using the getRows function, where you can specify the number of rows per batch. So in the earlier 2 methods, you will generally know the number of rows that are to be returned. However, if you do not know the number of rows that are returned and you do not know when it will be available, it is good to use the query stream method. So the query stream method will stream the rows until all the rows are returned. So every time a data event is triggered, that is whenever a data is available, you will get 1 row returned to the application. So quickly moving on to talk about, so regardless of whatever method that you use from the earlier slide, there are always 2 internal buffer size tuning parameters that you can set. One is fetch array size, the second is prefetch rows. We have 2 such parameters because of the way the internals work for node-oracledb and the underlying Oracle client libraries. They operate at different layers and they operate at different points of execution of an SQL or a PLSQL query with the node-oracledb. These parameters do not affect how and when the application rows are returned to the application from the DB, but they will affect the memory that is being allocated on the application side for these rows that are fetched. And increasing these values will use more application memory. So there is always a trade-off between the memory as well as the efficiency of the data being fetched. So this slide here shows a scenario where you're selecting a large amount of data and you're bumping up the default values of these 2 tuning parameters. A key note is that you should be tuning these parameters in your production scenarios, but they should be based on your actual loads and the network latencies. Quickly moving on to the next slide. So here what we have is a scenario where which you will encounter if you are paging data. So it is generally this scenario will generally happen when you are creating a web page and when there are multiple pages and you have to fetch a limited number of rows for each page. So here we have 20 rows. The trick here to reduce round trips and to tune your application is to set the prefetch rows equal to 1 more than the number of rows per page. So this additional value will stop the extra round trip required to detect the EOF pointer when you're fetching a page of rows. So to sum it all up, this slide shows the effect of changing the prefetch rows and the array size parameters for a different number of rows returned by the whole query. So we start with the default prefetch rows and array size. Default for prefetch is 2, and for array size it's 100. So as you can see, as the number of rows increases from 1 to 10,000, the number of round trips also increases if you retain the default values. But if you have an unknown large number of values, it's always good to set the array size to a higher value based on your network load, as we had said earlier. So if you set the array size to 1000 and prefetch rows to 1000, you can see that the number of round trips reduced to 11, even when your number of rows are very high, like 10,000. Compare this to the earlier table, where you can see that the number of round trips is very large when there are large number of rows. So there are a few callouts here that shows you how we calculated the round trips. Finally wanted to talk about the page of rows as well, which we discussed in the last previous slide. So always good to set the prefetch rows to 1 larger than the number of rows that you return per page, which will give you the optimum number of round trips. So, Chris, you want to take over?
Yeah, sure. And I see we're going to have to rush through the last bits of the slides. So that was standard relational data, lob data, long objects you can treat specially, and we can optimize the code paths by setting one of these two methods here. Obviously commented out the first one, but that's the global setting, or you can use the per query setting, the fetch info. And this says to the Oracle network layer, don't send me back a lob locator, which then I have to stream from and do extra round trips to get the data. Just send me back all the data at one go. And there's an equivalent fetch as buffer, OracleDB.buffer for blobs. This turns out to be the fastest way to get lobs. The small limitation is that this is restricted to 1 gigabyte or less of data, but it's very efficient. Would recommend you start with this in almost every case. Obviously, if you are streaming video or something like that, you will need to then use the node-oracledb lob class to stream huge lobs and fetch chunks of data at a time. Let me just continue on, Sharad. So we picked one topic, which seems to have come up recently, which is how do I work with multi-value where-in clauses? A lot of people think they can just have one bind variable placeholder. That's not true. You actually need one variable per data item, as you can see there, B1, B2, B3, and we have 3 data values in the binds array. This works kind of nicely. The thing we want to emphasize here is that you may not know how many binds you have. If you've got a web form, you may have different numbers of input values, but you don't want to be executing different SQL statements with different numbers of bind variables, because the SQL text changes, and that means we have to reparse a statement. The statement cache cursor can't be reused. The cursor itself can't be reused. It's better in that case if you know you have a fixed number of binds with an upper limit here, 3 max. Maybe we don't know that the third in this example I just showed at the bottom, Ali, Gita, don't know anybody else. So we just pass a null in there, and that lets us reuse that SQL statement and all its context and give you maximum efficiency. You might use, instead of passing lots of nulls, you might have buckets. So you might have, a statement with 100 bind variables if you've got close to 100, statement with 10 if you've got close to 10 bind variables. We'll leave that up to you to optimize. Obviously everybody loves optimizing, but only optimize when you actually need to. So suitable when number of binds is small, allows that statement reuse. The next biggest case, I guess, is what happens if you have very, very large lists. So in statements themselves in SQL can't have more than 1,000 values, and you may have a very dynamic list number of statements. So the good solution, blessed by Optimizer team at the moment, is to use a named type. Actually, there are a couple of named types out there that people use in overload for varchars and numbers. Here I've created one dedicated for this example. And then as you can see, and we don't have any other examples of node-oracledb's object support. This is one case that we're able to bind this object that we just created directly to the array that we're passing in. So we just have the one bind variable here using the table function in our SQL statement. Now, 2 things to watch out for. This is relatively slow working with objects. Make sure you use a fully qualified name. There's a cache here in node-oracledb, so we can reuse some of that object information if you're re-executing this in the same connection. And just avoid using this in small cases that I showed on the previous slides. The previous slides we use 1 round trip because straight execute. This, as it's shown, will probably use 7 round trips. If you've got huge amounts of data, this is the way to do it, of course. That's just the cost of working with big data. The Optimizer team also would like you to be aware that you should check if you're including this in a much bigger constructed SQL statement. Just check the Optimizer plan to make sure this lack of bind variable peaking in the table clause hasn't kind of caused things to go askew. DML, Sharad, do you want to talk about data manipulation language, inserts, updates, and things like that? Sharad, you with me? Otherwise, I'll just cover it. Okay, I've lost Sharad. Let me just continue. Maybe we're talking over each other, but I can't hear him. So
can you hear me now?
Oh, yes, now I can hear you. Okay, you're back. Sharad, go ahead.
Okay. Sorry, some network connection there. So we had talked about fetching data and we had talked about connecting. Now let's talk about how to load data. Here, this is a single row loading of data. So it's quite easy. It's similar to fetching data. You use the execute function to load data into the database. Of course, you have bind variables which you can in which you can do a runtime binding of the values which you need to load to the data. And binding is always recommended because it will help you to avoid SQL injections, and it is a very secure solution. So we always recommend you to bind. And also one more attribute that you see over here is the auto commit attribute. The auto commit attribute is efficient. It will piggyback along with the execute function to commit the data onto the database. This is much better when compared to an explicit commit because it saves one round trip for the user as well. So quickly moving on to the next slide. So what about arrays of data, or what about multiple data? So here, what you want to do is to execute one data manipulation language statement, DML statement, and with many data values. So you can do it by two ways. One is having the execute function and then looping over the multiple sets of data, but that is very inefficient. So we recommend that you use the execute many function, which does all of this in one go. One more additional parameter that you can see over here is the bindefs attribute. Bindefs attribute is used to avoid having to scan all the input data to reallocate memory. So as you can see, the f type of the f variable is set to string, and the max size is also set. So this will make the the SQL calls very efficient, and when you extrapolate it up to a very large load, it can save you a lot of, it can bring in a lot of efficiency and optimize your application to a large extent. Moving on. So what about now you have a large data set, and what if you have noisy data in the set? So batch errors is a really useful option here for large data inserts with potential noisy data. Here, as you can see, we have introduced noisy data of then a null data, as you can see, for the key column over here. And when you set the batch errors equal to true, and when you run the execute many command, quickly, if you can, you can see that the batch errors show you where the errors are and where the invalid data is within the function. So one quick note here is that if you have invalid data, then the auto commit function will not commit the valid data also to the database. You will have to correct your errors and then rerun the SQL query, and then do an explicit commit. So that is how currently it works with batch errors and invalid data. Quickly moving on. Okay, time for some benchmarking now. So this slide here shows a time-based graph of using execute loop for n number of rows versus using execute many once for n number of rows. As you can see here, as the number of rows increases, execute many wins over execute loop by hands down. For example, for 10,000 rows, you can see that it takes only 39 milliseconds for execute many, and for execute loop, it takes around 24 seconds. So that is the great advantage that you have on a normal use case here. Here we have used only a local network. So if your database is on a remote network, the gain with execute many is 10 times or even 20 times higher. So as well as the so this will also give you the gain not only from a overhead of executing each individual execute functions, but also the effect of round trip costs here. The number of round trip costs are reduced by a large amount, and we always recommend you to use execute many function. Quickly moving on, please. Okay, now let's quickly talk about JSON. JSON, developers love JSON because it supports dynamic schemas and makes schema changes easy. Oracle introduced the SQL JSON Open Standard. It introduced the JSON data type in its latest version 21C, which uses its own storage format called OSON storage. Earlier versions of Oracle used log storage for JSON. So we recommend you to be careful when you're coding for apps that run in a mixed version environment. You can always check out our GitHub for node-oracledb to look for examples on how to run in a mixed version environment. However, here we are taking the latest version. We have created a JSON data type. Sorry, we have created a JSON data type, and we have this node Oracle DB example uses the latest JSON data type. It also has the DB type JSON attribute, which it uses to get the JSON data back in its newest format. So running everything quickly, as you can see, you can bind a JavaScript object directly for insert using the new type db underscore type underscore JSON, and querying will give you the JavaScript object directly here, as you can see from the output below. So, Chris, you want to talk about Soda?
Sure, Soda. Thank you, Sharon, for that excellent coverage there. So simple Oracle document access, the Soda style, has been around now since about 18C Oracle database. It's an API which is available through a number of languages: PL SQL, REST, Java, C. By default, documents are JSON. So we saw earlier, Sharon just showed the SQL JSON functionality, and there's a whole lot there. There's a lot of JSON functions themselves in SQL, and there's a whole office hours and manuals and things on that. That's an interesting specialist topic. Soda is a different topic. By default, it uses JSON, doesn't have to use JSON, but most of you probably will be using JSON. Underneath, it stores everything in tables, so it has all our tried, true, trusted technology. Has simple query by example. I'll show that in a little bit. You don't need to know anything about SQL, but because it does actually use that table storage underneath, you can really do some advanced analytics if you really want to for specialist purposes. So in node-oracledb, we represent it through the same classes that you see in other languages. There's a base Soda class, almost a placeholder in node-oracledb. You can have sets of documents stored in collections, so that you can think of this as a table if you're trying to map it into the old school. You have an operation builder, so you can do query by example stuff on this, and you can get multiple documents back if you're retrieving documents, or maybe a single document. And obviously, you can create documents and then insert those back into collections as you like. So in node-oracledb, you need a couple of privileges. The Soda app privilege, I think this is already in the resource role in some environments. Table back, so you need to be able to create tables, and you can create connections. Now here I'm showing the Soda metadata cache, and that's something which is available only if you're using the pool. So again, for many reasons, recommend using pools. Has high availability features. We'll probably show in our next session in a couple of weeks. But here, in 5.2 of node-oracledb, we introduce the Soda metadata cache, and as you can imagine, caching is good, reduces round trips backwards and forwards to the database. Interestingly enough, it works with the open collection, but not the create collection for various reasons. Create collection won't return an error if a collection already exists. It will do an open, so it's like an open or create model. But what I showed there on the slide is the most efficient way of doing the explicit open, so we can reuse the cache if the information about the my collection is in that cache, and only then do we actually go and create it if we need to. So we have a bunch of methods we can use, batch methods. I don't think I have examples here. Insert many. This is just the insert one, taking a straight JavaScript object, inserting it, and in the second example, we do an insert and get. When you do an insert, you get, when you do the insert, you automatically there is some metadata created. In this case, I'm looking at the key from the return document, and that would print out, oops, sorry, I don't have the example there. In this case, it's a UUID, which gets printed. You can customize that when you create collections if you like. So the operation builder find is a set of non-terminals followed by a terminal. So here first example is taking the key perhaps from the previous insert and get, and then just getting back a single Soda document. We can then access the content of that document in whichever method we like, object, string, and I don't show the buffer method here on this slide. There's a query by example I mentioned. Again, this is this kind of non-terminals. We build up a bunch of non-terminals, and then we have a terminal at the end. So this is filtering, standard, you might recognize like, so S%, so anything which starts with capital S. I've thrown in a fetch array size here. The default is 100. It's based off the standard OracleDB default values. As we saw with the round trips, this can reduce round trips and improve performance if you're fetching multiple documents. And then obviously a loop, looping over the documents, getting the content, and as printing out one of the attributes inside each of those documents. And that's it. We just really ran out of time today. We budgeted, I think, perfectly our time, I would like to say, only a minute or so over. And we look forward to catching you in our next session, where we can do a bit more of a deep dive into some of the high performance capabilities of node-oracledb. That's on December 10th, 2021. Please do let us know if you're using node-oracledb. We get asked always internally who's using it, why we should be putting resources into it, how many resources, and it's just useful for us to say, hey, big customer X, these people are using our drivers. We have a significant number of downloads, but just knowing the number of downloads often isn't a good argument when people are saying, well, is it stable? Is it growing? Who's using it? Who's really using it in production environments? And we love hearing from you, love hearing quotes, etc. Please get in contact with us on GitHub or send us email. We'd really appreciate that. And follow along our blog and see all of the latest stuff which is coming out of our data access group. So thank you, Sharad, for all the work you put into this presentation, and Francisco and everybody else at the conference for organizing things. That's the end for us today. Thank you very much.
Thank you. Thank you.
All right. Thank you so much. And thank you so much again. Is no questions at the moment, looks like. But if we have any questions, you have in the screens all the emails from Sharad, from Christopher, and also you can contact them, find them very easily from Twitter, and they will be more than happy to answer any questions, if not now during the playbacks. Christopher, Sharad, thank you so much for taking the time to do this. And please take care, be safe in these pandemic times, and hope to see each other very soon face to face.
Thank you.
Thank you, everyone.
Thank you, Francisco. Thank you.
Bye-bye.
Thank you, everyone. Bye-bye.
Bye-bye.
CloudDB, shaping your new normal.